All right. Hello, guys. We're gonna start here. For all of you wondering that you cannot connect with audio or video, that's normal. So don't worry about that. As long as you can see us and hear us, we're good. So we're gonna start. My name is Mara. I'm with LDM here in the United States. Thank you all for joining us for this webinar. It will be imparted by Craig Hoverman. He is the director of Buckley's and the new business manager. So I'm gonna let you, Craig, take it over from here.
Good morning, everyone, and thank you for having me. Hopefully you can see my slideshow that is appearing up on the screen. You just confirm that for us, Mara?
What is that?
Can everyone see?
Can everyone
can see my screen? Hopefully so.
Oh, and one more thing I forgot to mention, for all the questions that you may have throughout this webinar, please direct them to the question and answer section, and we will review them at the end of the presentation.
Okay, so let's get started. So I don't know how many people have heard of Buckley's before, hopefully a few of you. So this morning we're going to talk about electronic leak detection, what that is, and hopefully how our product is going to assist you in finding leaks on flat roofs or non-conductive coatings. So let's get started. So the first method we're going to look at this morning is our high voltage leak detection method, and that is been around since about the early 1960s, where Buckley's has been supplying machines like these to the industry, predominantly for pipeline testing. Now, where oil or gas pipelines may run on the seabed or or put in the ground, a coating has to be put on those steel pipes to protect them from corrosion. Now, with the steel being the conductor and the insulator being the coating, a machine could be used, such as a holiday detector or pinhole detector, to find out where the holes may be. Now, in about the early 1990s in the UK, clients realised, as well as ourselves, we could supply machines for finding holes in flat roofs. Now, those materials, such as single-ply membranes, bitumen, TPO, etc., are a good insulator, and with that being on top of something conductive, predominantly you could find the holes. Now, around the world, we've been selling these machines, and it's been since about 2017, when the latest model we have coming out now, which is called the Dry Roof Pro. You can carry out tests from any type of material except really EPDM. And this type of method could be called high voltage, ELD, electronic leak detection, dry roof testing. There's lots of names in the industry. So how does it work? Predominantly, you need a good conductor underneath your material you want to test. Now, that conductor could be steel, foil face insulation, it could be concrete. They're predominantly the best types of conductor underneath the roof covering. Now, other types of conductive layers may be put in between, and there are many in the industry today, and you may be familiar with some of those conductive primers, which are like a sprayed or painted on underneath the membrane, or it might be a actual layer. In the European market, they have a company that supplies like a conductive layer underneath. Now, as you can see in the picture, all we're going to do is we're going to earth our machine to something that is conductive. In this scenario, we have a lightning conductor that's up on the roof. And we've taken a cable, an earth cable, to our machine. All we're going to do is set a defined voltage to the machine dependent on the thickness of the material, and we're going to start brushing over the top of the insulator. Now, as I said, that could be single ply. In this instance, we're using this is a single ply. And as you go across, by sweeping across the top, if there was a pinhole, and literally if air could get through it or water could get through it, you wouldn't be able to see it by the eye. The machine would pick that up. And what that would do, it would spark to the conductor underneath and make a circuit back to the earth. Now, if you didn't have that conductive layer underneath, but water had penetrated your roof, the likelihood of sweeping across the top of the material, again, the top layer has to be dry, but say there was water in between the material and underneath, the machine would pick up the water path, and hopefully, therefore, you would find the route to where the hole is. So that's a brief indication. It does say in the slide there, if you were to use too high a voltage, you could actually burn a hole through the material, and we'll go on to that a little bit later. Basically, everything you need in a kit. The machine runs off D-cell batteries. All you need to do, literally, charge your batteries up, pop them in the back, and you've got everything in the kit ready to test. Although we talk about two different methods, one is high voltage, one is low voltage, being a wet system, the safety warning and the information we give regarding the high voltage piece of equipment must be taken into account. Now, this machine can go anything from 2,000 volts, up to 40,000 volts. So we've really got to make sure that you use it in the correct way. So there is a few safety warnings that we need to get across to you. If you do have like a heart pacemaker, cochlear implant, or anything like this within the body, we do recommend you don't use this type of equipment. And the other thing is you don't use this in any combustible atmosphere. So predominantly up on a roof, it should be well ventilated, but we just need to make sure that the area you're testing in, you are going to ignite a spark, and therefore that could generate an explosion. So we don't want that to happen. The other thing that we need to just talk about really is that being high voltage equipment, the machine is going to look for its quickest way back to earth. Now, if you do not have a good earth with your machine, you potentially will become the earth. And if you were to come into connection with the brush, for example, when it was on, you would receive that electric shock. So we do need to make sure we're showing it correctly. And if you do need training, we do offer that. So moving on to a little bit more about the machine. It's quite straightforward to set up, really. All you need to do is, once you've turned the machine on, obviously make sure the machine's earthed first. You can see the different functions of the machine. Basically, the voltage that is given for the machine to work out the correct voltage for the correct thickness is dependent against this standard here. So the NACE SP0274 standard, if you were to look that up, you will find that more to do with how much voltage could be delivered for a particular thickness of coating. But this is more for pipelines. Now, over the last, say, 20 to 30 years, where these machines have been used on roof membranes, this standard, it seems to be heavily adopted. Now, you'll notice on here, this is in microns. You can change the machine into imperial if you so wish. And therefore, as you push the plus button on the machine, that will increase not only the thickness but also the voltage above. And that's already taken care of by the machine for you. The other thing is to take into account on this machine is how you actually, some questions that come up a lot with clients is that they may test a material in the morning and it's quite cool conditions, but in the afternoon, the machine's constantly alarming at them. So what this sensitivity button is, again, you have a range. The lower the sensitivity, the more sensitive the machine is, the higher the sensitivity, the least sensitive. And what that does is when you place your brush onto the material and go across it, you'll get a current flow, the amount of current being drawn, and that would be shown, and it will constantly change as you move the brush across. Now that would also depend on what size of brush you may use. So most of the kits that we supply do come with a 450mm brush. If you do want to go to that larger brush, you need to keep an eye on that sensitivity settings. Also, the material that you're testing may have a consequence. It might draw down the voltage. So we need to keep an eye on many factors when setting up the machine and using a different size of brush, or keeping an eye on the actual weather conditions as well to see if we need to change the settings of the machine when carrying out a test. So just in the quick setup operations is that you've got many, you've got like a warning tick, so it will go off constantly as you use the machine. Now that is for your safety. So then if the machine's constantly ticking, hopefully yourself and other people around you will know there's something going on. The DC sense, you just click on this button here, the settings button, and you can change the sensitivity. You can increase volume, and then the formatting, you just change that from metric to imperial if you wish. Now, if you do not wish to use the set formula, which is the SP0274 standard, you can turn that off. Then you are reliant just on yourself knowing what voltage you may want to use. Okay, so that's enough about the machine. How do you actually use the machine, and how do you go about doing a test? Now, many people will test in many ways, but a good way is to start in one corner, and every area that you cover with that brush is a part that you potentially have tested. Now, we say mow the lawn. You can start in one place, just go up and down, and therefore hopefully you'll cover most areas with the larger brush. Now, if you do need to go around some more decorative areas where there may be an upstand on the roof, or some areas where the larger brush isn't ideal, we do supply in the kit some smaller brushes which you can then put onto the handle and just do a bit more decorative area testing to see if there's any holes in that area. So that talks a little bit about the dry kit, hence the name, the Dry Roof Pro, just remembering that that roof membrane has to be dry. A good way of identifying this is if there is dew, or if there is some sort of water on the car or on the van, on top of the van, when you're going to a site, then predominantly there's probably going to be some water up on the roof. So you need to let the weather take its toll to burn that off. Okay, so that's a little bit about dry testing. Surely there will be many questions, no doubt. But just like the dry, and now going on to the wet, predominantly these machines work best when they're non-conductive materials. Okay, so we do need to look out that these materials are non-conductive. Okay, so the history, a little bit about the wet system. You might have seen this over in America quite a bit, is that the wet tester was firstly brought out in Germany in about the early 70s, if I can get my dates right. And in about 2008, we brought out a version of this when a patent actually elapsed. So The wet machine for us is a little bit newer, but a very good machine, especially if you've travelled many miles to carry out a test, and you can therefore have the option of testing wet or dry. So how does this machine work? Now you need a good flow of water, so a good millimetre or plus of water. In the picture here, you can see there may be a little bit of a dry patch. You do, for best result, a good flow of water. So again, a nice non-conductive material. Ideally, the sort of questions you want to ask yourself before going to maybe go to this site or ask some questions. What's the roof makeup? So if you had a single ply or a bitumen on top of concrete, great. Or if it was on to insulation, but there was a conductive layer in there, or there was foil-face insulation. The water is the means of your test. So once you've set the machine up, and there is some videos on our YouTube channel if you want to go and have a look at some of those. This is your generator, and you're going to pulse the area of test at 32 volts. One of your wires will go to the earth, and the other one will go to what we call the trace wire. Now that is the wire that you place round the roof for the area that you're going to test in. So check firstly you've got a good earth return once you've set the machine up like so. And you can do that by putting one of your poles, like in the picture, inside the trace wire, and the other pole onto something that's actually conductive, outside predominantly. Now, you'll notice here there's an isolated shaft. That, in a way, it could be that water's going down it. Now, that could identify to your machine that could be a fault. So what we need to do is just make sure we just put the trace wire around this shaft. It's the same as if there was a hole over here, you could just move your trace wire to make sure that you wouldn't get a signal to your machine if you had multiple holes, for example. So once you've set the machine up, what you're going to do is you're going to go on to the next slide. There it does. There. Oh, gone a couple there. Sorry about that. So we're going to try and visualize how you're actually going to carry out this test. So you've got water all over the area, and a good way of understanding the voltage is that if you throw a stone into water, you get a ripple effect. And think of that stone being the hole, and the generator is going to be pulsing that voltage, and what happens is that voltage will constantly pulse onto that roof in area. Now with the detector, and this is the detector screen, if you place your two poles down, which ideally are shoulder width apart, place those two poles down onto the material, and if there was any flow of, the machine would be looking for a current flow in the water to the conductor over here, the machine is going to indicate to you where that hole is. So where the dry machine would go straight across the top and indicate exactly where that hole is with the spark jump into the hole, this way is going to be a little bit more labor intensive, and you will then have to move your poles over to ideally find where that hole is. Now if you're right above it, like the two poles here, you probably won't get too much on your display. You might get a flicker one way or the other, but as soon as you go past it, you'd then get a direction back the other way. And then you could home in on the area where you may need to patch. Okay. Again, there's a few safety warnings with this machine. It is 32 volts. I'm not telling you to do this, but it is something that I did when I was a child. You put the 9-volt battery on your tongue. That's the sort of tingle that you might receive. I'm not telling you to do that, but it gives you an idea potentially of the sort of shock you might get on the wet machine. Now, everything in the kit again you need even comes with some crayons there to mark up on the roof, and you just put the machine together. Here's your detector in this slide, and you basically put your poles together, connect it up, and just make sure you don't cross your poles over, because if you're going to cross your poles over, then you might go in the wrong direction. But it's quite straightforward. You have the magnification button there, so you can increase that sensitivity of the machine, and that will give you an indication left to right. The generator, a little bit like the dry kit, it does have a amount of current being shown on the machine. Now this is in milliamps rather than microamps on the dry, and when you set the machine up, you'll see this little bar go across the screen back and forward as the voltage is pulsed onto the membrane. I meant to mention, sorry, on that slide, is there is a sounder. So when you are going across the roof, there is a sounder that you can turn off if you wish, and that is so that you can hear that when the sounder goes off, you keep your poles in connection with the actual membrane, and that will give you the indication to go left or right if there is a breach. The other couple of things on this slide is that there are speed settings as you wish. There's 3 speed settings depending on how quickly you want to move. It really depends on yourself and how familiar you get with the machine. Okay, so just like the dry, we've got a bit of surveying method. Once you've got that trace wire around the area you want to test. If you look at on the slide here, you've got some green lines, and that's sort of like showing like the lap joints. We can't actually test lap joints because there may be 80 mil, maybe more. But what the machines can do, if water had penetrated through the lap joint, then the machine would pick up the fault. So I like to tell people the benefits to the machines, and sometimes there are a few negatives, but predominantly these machines are great to finding faults on flat roofs or any non-conductive material, and you'll probably see that a lot of machines are used out in the industry. Hopefully yourselves can be using them soon as well. But anyway, the lap joints are a good tool to actually do the test. So if I was standing, I don't know if you can see my cursor on the screen, hopefully you can. You start in one area and you go along working a bit like a crab in a way, and you walk along to the left, then back onto the right, and you're going to place your 2 poles down, and once you feel like that area has got no fault, you can move on to the next area. Now, how big can you put that trace wire out? It does come with a 200 meter trace wire. I don't recommend that you put that 200 meter trace wire out completely. The best idea is to segment the areas you want to test. So it might be that you put take the trace wire around the whole area you want to test, and then carry it on and make it into some smaller sections so it's more manageable for the testing. Okay, so types of flat roof. Now there's many types of roof, and it's not just flat roofs. We call it flat roof testing. It could be many different types of material, even from enveloping when even up on walls before backfilling, for example. But single ply, felt, liquid, asphalt, hot melt, TPOs, there are many, and all we would say is that if you are unsure of if that material is testable, get a small sample, put it down onto something conductive, and carry out a small test first. And if you're still unsure, we do carry out tests at our factory. Most weeks, clients will ring us up asking questions about different materials. So hopefully that gives you an insight. Standards, documentation. There is an Astm standard for electronic leak detection, or should I say just leak detection, really. You could go and have a look at that. I am trying to work with the Astm and with the Astm waterproofing sector to try and bring out some further guidance on leak detection using these two methods. And again, there are other methods out there. It's not just these two. I like to think these two are leading the way for the type of testing that will find holes for you. Now, what should be in a test report? Now, lots of different companies will say lots of different things. This is just a little guide, maybe what should be in it. I always say to clients, be careful on number 8 there, which is your recommendations, because obviously it depends what you may have been asked by your client. For example, if you've been asked to carry out an integrity test or a survey of a roof and pass over your findings, it might be that recommendations isn't part of the report, and you need to make sure that you may be covered for giving recommendations in case that may come back to bite you in the future. So that gives you an idea. We do offer training for these machines, which does have sort of a manufacturer's certification. LDM obviously will be able to help you in America and in Mexico and other territories around the world that they look after for us. And as that comes to one of the last slides on my show, I'm just going to just show you the references. This might be a slightly old reference, but this magazine in 2010 published some information about testing, and there is some various methods from flood, which has been predominantly the go-to, I think, around the world for many years. There is other methods, and you'll notice these are the two that we've talked about here is the high voltage and the EFVM. Now, something to just mention, and I'm always wary of this, and sometimes it says test under ballast using the wet system. I do know a few clients that have had success finding holes in membranes when testing on top of green roofs or stones on the top of the material. I haven't seen it personally myself. Some clients in the UK have told me it's worth having a go doing these type of tests, but I'm yet to be convinced at the moment that testing on top of ballast or green roofs will give you great results. I'm not saying it can't be done, I'm just saying that I haven't seen it personally. So that sort of comes to the end of my little talk about these type of machines and electronic testing. Does anyone therefore open the floor for a few questions?
Yes, they have some questions. I'm going to read them to you, Craig.
Okay.
Ask, can you use this machine in water ponds? Dry, of course. They are usually made with HDPE over dirt.
So are you talking more about geomembranes here? Could you just repeat the question, Manal? I just didn't quite. I think there might be an interference on the line.
It says, and I don't know which equipment they're referring to, but it says, can you use this machine in water ponds? Dry, of course. They're usually made with HDPE membranes over dirt. So I'm assuming it's the geomembrane.
So you can use them. So yeah, so like a pond reservoir or something like that. So yes, you could use the dry tester. Probably would be better for you when it would before it's actually filled up with water. I have known some clients in Asia that actually have carried out tests in like a reservoir or pond area with our wet machine also. It is a quite sensitive machine. You would need to get some sort of trace wire around. I don't have great knowledge of that. I would have to maybe speak to some further clients that may have had some experience and then advise, if possible, to that particular person.
All right. Second question from Elias Rodriguez. If we don't have an earth cable, can we try to connect to building structure?
Yeah, so you still need an earth wire to go to the machine, but sometimes as long as it's something connected or to the structure of the building, that would be fine. So and the way that you can test is once you've placed, say it's a bolt from an air conditioning unit or something that is mechanically fixed to the building, what you can do is once you've set your machine up, place your brush when it's going onto something that is somewhere else that is earthed, and then if the machine alarms at you, that tells you that you've probably got a good earth.
Okay, and another question from Chad Smith. Just wanted to confirm if a conductive layer is needed in the roof system for the wet roof pro.
With both machines, if you've got a conductive layer straight away underneath, that is going to make your life a lot easier because you've always got something conductive to test back to. If you do not have something conductive, you may be reliant on water to have penetrated your roof to actually find where the hole may be. So if you've got a conductive layer straight away underneath, and I'm not a roofing consultant, just to make people aware, this is my experience from working with Buckley's and these type of machines, how a conductive layer may be underneath the material. Obviously you need to go and find that information out by the various specifications that may be out there. But if a conductive layer is underneath that material, the water would hit that conductive layer straight away, indicating a better, or probably indicate to you on your wet machine a lot easier the direction of which way to go, because the water is hitting the conductor. Same with the dry machine. You've got something conductive underneath. When you go across the top of the voltage, the spark's going to jump to the conductor underneath. So if you do have that, and I think what some clients are doing around the world, it's been a lot more specified, I think, to have a conductive layer, because if there is a fault in years down the line, this type of equipment is available to carry out a test. So if you do have a conductive layer, and if you do want to get in contact with some companies that do conductive layers, let me know after and I can assist you on that.
All right. The next one is there a CSI master spec section for these operations?
Oh, good question. I wouldn't know about that, but keep that question for after. I'll investigate that one and we'll let the person know.
Okay. And then the next...
Sorry, carry on.
The next one is, does this system works on a green roof? Yeah,
so that's what I was talking about. You may have seen pictures around on the internet about where the electrodes are on top of the green roof. I have, as I say, I do know some clients that have categorically said, yes, you can do this. I haven't seen it myself. And I have known a few clients in the UK to say they have would try utilizing the wet machine, because giving it a go and finding an area where there may be a potential leak is better than ripping up the whole roof. So have I seen it? Yeah, as I said, I haven't really seen it myself. But if it's something that clients are more interested in, surely we'll be able to do some more tests to carry out, find out that information and actually advise a bit further.
All right. So the next question is, what will happen if too much voltage is used?
Okay, so yeah, very good question. Voltage, if you do use too much voltage, the likelihood is that you'll burn a hole through the material. So with any non-conductive or coating, you have something called dielectric strength. And dielectric strength is how much voltage you can apply to a material before it would break down. Now, we do a lot of tests on a lot of materials as clients or manufacturers send us their materials. And most materials are dielectrically quite strong. What does that mean is that you can carry out a test yourself, and I suggest you do it on a small piece of off-cut of material and do this in your not up on the roof. Place your material down on a piece of concrete. Make sure you've got your machine earthed particularly well, and then in your kit you have what we call a pointed probe. Place your pointed probe onto your handle, and then you can carry out a test of placing all that energy from how much voltage you may have set, and just leave it in one position for maybe 10-15 seconds or longer, and you'll see if the material starts to break down. As I say, most materials are pretty dielectrically strong. Now, I'm not saying this is a rule of thumb, if you understand this phrasing. If you were to look at a piece of material, if it's quite solid, in my experience, most materials are quite, maybe a little bit, the dielectric strength is stronger. If they're a little bit more flexible, I've found that certain materials, maybe the dielectric strength is slightly weaker. Now, that's only my experience that I've come across, and that may not be the case in every circumstance, but it gives you an idea. But again, you can work this out. You can have a go at doing this yourself. As I say, if you've got the high voltage machine, place that pointed probe on, and just slowly increase the voltage, and you'll see at the point when it may break through.
All right, we have one more question. It says, how would the Wet Roof Pro work on picking up a hole in a roof membrane that doesn't have the conductive layer underneath, since the water wouldn't ground the system?
Okay, so as long as you can connect on the roof somewhere that's conductive to make sure you can ground the generator. If water has penetrated the roof, now it obviously depends on the type of roofing makeup. If I was to say it was some sort of steel, corrugated steel with a concrete layer, and then it had 150 millimeter of insulation, it might have a vapor-proof barrier in there as well, then the material on the top. If water had penetrated and it was coming into the building, that would hit something conductive. If you do not have anything conductive whatsoever, the likelihood is you're not going to find any indication on your device, because the machine's not going to be able to pick up any water hitting anything conductive.
Okay, we have one more question. Is it possible to use the Wet Roof Pro when the substrate is wood?
Okay, so yes, not necessarily the wet machine, but I have known clients to test on top of, if the materials are on top of wood. What you can do, you need to make sure you've earthed your machine, your dry machine up on the roof somewhere. It needs to be a good earth. What you can do is, if say water had come in and there was a wet patch of underneath where the wood was, what some clients have done is tapped like a nail into that wood area where it's wet, attach a separate wire to that nail where in that area, and take that up to your machine. What you'll do is, as you pass across the roof on the top, if there was a fault, the brush would hit that water path and then making your circuit. So there is a way. I do know many clients have been successful testing like that.
Okay. And we have two more questions. On a wet roof, what is the max height water recommended?
So I do know clients have been doing in a foot of water. Some people, you know, an inch worth of water is probably best. A good flow of water. The sensitivity of the machine is very good. So I would have to come back to you exactly the amount of water in terms of height, but I do know probably a foot of water is okay. Okay.
And I feel like the last but not least, it says, can you use this on water tanks, vertical walls, and in which machine will you use, wet or dry?
Okay, so the likelihood of you testing up a wall with a wet machine is pretty slim, because you need to make sure you've got a trace wire around, as well as you're not really going to have water staying up on the wall as a nice flow of water. So the wet machine is probably not going to be the machine for that. If you're doing, let's say, enveloping, or the wall, the upstand of the wall is the insulation coated for waterproofing, then as long as that's onto something, again, conductive, you could carry out a test using that dry machine.
Okay. I guess we have one more question. It says,
okay.
Wet roof. How would the system operate on a TPO roof without a conductive membrane?
If it doesn't have any, so if it's a TPO onto something that is not conductive.
Yes.
Yeah, unless water had penetrated your roof, and the water was therefore maybe hitting something conductive, eventually the machine wouldn't pick that up. It needs to hit something conductive for it to signal to the machine.
All right. And I guess one more. It says, is there any prevent maintenance to consider?
So these machines, we do say on a 12-monthly basis you should have these checked. The dry machine is a calibrated piece, so it is recommended every 12 months you do get that service. We do recommend that as well the wet machine is done at the same time. That's more of a certification of test to prove the outputs, really.
Okay. All right, well, I hope that we answer all of your questions. We have come to an end. Thank you all for joining us. We will be sharing this presentation with you. Thank you, Craig, for your time, and hopefully
thank you.
Do this again.
Yeah, thank you very much, everyone, for joining us, and hopefully the information that we've passed over this morning is some information that you'll go forward and utilize for testing in the future. If you need my details, I'm sure LDM will pass them on. I'm more than happy to have a chat with many people if they want to discuss about these type of products.
All right.
So thank you very much.
We'll be talking. Bye-bye.
Thank you. Bye-bye.